this is pre-calc. This is the graphing part of conics. So we'll just look at 7 through 11. So we'll do one of each kind, and then the hyperbola, we'll do it where there's one of them where the vertices run horizontally and another one where the vertices run vertically. So we'll do 7 through 11 with graphing. Okay, but first I'm just going to look at how we decide when it's in standard form, how to decide if it's a conic. So with the circle, we've got 2 squares, and it's not a fraction. It's equal to 9, it's not equal to 1. So when they're in standard form, both the x squared and y squared are squared. Both x and y are squared, and there's no fraction. Here, we know this is an ellipse. Okay, so we have x is squared, y is squared, and we're adding 2 fractions. If we look at number 9, this is a parabola. So how do I know it's a parabola? Well, because only one of them is squared. We just got an x squared, and it's on the left. So this is when they're in standard form. And this is the way it'll be on the test as well. All of the graphing ones will already be in standard form. All right, number 10, this is a hyperbola because we're subtracting the fractions, we're subtracting the square terms. Down here, again, doesn't matter if x or y is first, this is also a hyperbola because we are subtracting the square terms. Okay, now we're going to go back and graph them. So we'll start with the circle. So the center of the circle in standard form is just the opposite of the x's. So this is the same as if it were x minus 0 squared plus y minus 3 squared equals 9. All right, so opposite of the x's is x minus 0. Opposite of the y's, x minus 3 is positive 3. So that's the center, 0, 3. My radius is just the square root of whatever it's equal to. So the radius is 3, which means to graph it, I'm going to go right 3, up 3, left 3, down 3. And boom, there is my circle. Take a look at the ellipse. All right, so just like the circle, the center is the opposite of the x's, the opposite of the y's. So I'll graph that, left 2, up 4. And then the vertices come from really the denominators. So if we were going to write the vertices, you can either write them all 4 out separately, or you can write them as a pair. So if I look at what we're doing here with the x's, that's square root of 4. So if I take this square root of 4, I get 2. That's what I'm going to add and subtract to the x's. And when I add and subtract onto the x's, that means I move right 2, left 2, right 2, left 2. Now this is the way it would look as those 2 vertices written as a pair. So we took whatever was in the center, we went right 2, and we went left 2. Okay? With the y's, I'll do that in a different color, we are going up and down. Y is up and down. Square root of 16 is 4. So from the center, I'm going to go up 4, 1, 2, 3, 4, down 4, 1, 2, 3, 4. Okay, so how does that look when I write it as a pair? It's going to be, the x's are just going to be the same, but then I'm going to take that 4 here, and I'm adding and subtracting this 4, that 4 there. And if I draw this, this is my ellipse. Now, if I prefer, instead of writing it like this, I could write them as 4 separate vertices. This point here is 0, 4. right? So if I look here, negative 2 plus 2 is 0, comma 4. I could write this one here as left 4, up 4, which is my second one. Negative 2 minus 2 is negative 4, 4. This one is left 2, 0. This one is left 2, up 8. So if I wanted to put those 4 points on this line instead, I could do that as well. Now the foci always are along the major axis. The major axis is the longest part here. So they're along here. So I know I'm going to add and subtract onto the y's because we're going up, down. So I'm just going to do my center, and I'm going to set it up so I'm adding and subtracting onto the y's. So because this is a plus, we're actually going to subtract a squared minus b squared. Now all a squared is the bigger denominator. So when I look at the top, I've got 16 and 4. A is just the bigger of the two denominators. So C is the square root of 12. Now square root of 12 is 3 point something. So if I were to move these up, so 1, 2, 3, it's just like right below the 4 there. Something like that would be where it is. Okay, so there's the ellipse. Parabola. The big thing here is we want to decide if it's going up, down, or right, left. So I usually start by looking at, we have a plane y and an x squared. So I like to just sketch it. That's y equals x squared. That's the kind of parabola we're used to, which is up, down. Okay, so this is going to be an up, down parabola. This negative means it's going to be down. So I just right away try to picture what it's going to look like. Now the vertex of a parabola is kind of like the center of an ellipse or a circle or a hyperbola. It's the opposite of the x's. It's the opposite of the y's, but just pay attention which one comes first, the x's or the y's. So opposite of the x's, opposite of the y's. Just kind of coincidentally, both of those were negative 2. But now I already know that this is what my graph is going to look like. That's what my graph is going to look like. My foci has to be somewhere in there. It has to be somewhere in there. So I'm going to move down. You know, it's up, down. So I'm going to move down from here. So it affects the y's. The question is, how much do I move up or down? So that depends on this. So I'm going to set this negative 10 equal to 4p. And negative 10 divided by that is negative 2.5. So I could write it like this, but usually I just graph it. I know I'm going to go down 2.5. Just erase this so we can actually see it a little bit better. And so first correcting the rest of it, but from the vertex, I'm going to go down 1, 2, about 2.5. That's the focus. That's the focus. So that was left 2, down 4.5. Then the directrix is up 2.5 from the vertex. So from the vertex, if I go up 1, 2, 2.5, that is just up half. Now that is a horizontal line, which is a y equals line. That is a y equals line. Oh, the focus I put in the wrong spot. I'll move that down here. The directrix is this. I'll label this on the graph just so we have that. Directrix. That point is the focus. And the axis of symmetry is just the line of symmetry. What is the line that divides that parabola into two? That is a vertical line. So this is x equals negative 2. Okay? go on to the hyperbolas, kind of try to point out the difference here. So with the hyperbolas, we kind of do it like an ellipse, but the big difference is this is where the vertices come from. Vertices. So the center is still the same. It's the opposite of the x's. If there's nothing there, it's a 0. Opposite of the y's. So this is my center. 0, -2. Then for the vertices, we're going to go right, left. So for these vertices, I'm going to go right, left, square root of 4, which is 2. So I'm going to go right 2, left 2. So if I'm writing that like this, it affected the x's. We're going to go right and left 2. So the 2 points were 2, -2 and -2, -2, if you want to write them separately. But then I'm going to try not to do this too dark, but these, that's what the parabola should look like. I'm just trying to sketch it so I know what to expect. And I should be able to expect that this is where the foci come in, all right? So this is a right-left parabola. So the vertices come from the first term, which is x's, and there I had to go right-left. Okay, and now I'm going to take this away. And by away, I just meant I wanted to take away the sketch. We are actually going to now go on to the non-vertices. So square root of 1 means we're going to go up, down, 1. This is a really tiny little rectangle. But I'm going to make a rectangle out of that. I'm going to make a rectangle out of that. And then we're going to put in asymptotes that go right through the corners of the rectangle. And they go through the center of the hyperbola. And asymptotes are really just a guide, so the graph actually never crosses it. So if this is a vertex and this is a vertex, I'm going to use the asymptotes to kind of guide the curve. I'm going to try to make it look like a curve. It almost looks like a V there. But it should be curving to the right, curving to the left. So the equation for those asymptotes, if we think of a line, you know, usually a line is x and y, x equals slope y. Okay, so we're going to put the slope here. For the x and the y, we're actually just putting the center. So after x, I'm going to put 0. After y, I'm going to put -2. I'll clean it up in just a minute. And then my slope, there's 2 different ways I can do it. I can either do the rise over the run of the rectangle. So this was a rise of 2, run of 4. And you could even just leave it like that. I mean, I might clean this up. The other way you can get it is because rise is always the y's. I can take the square root of what is underneath the y's over the x's. This got a little wonky, but run is always right, left. And this is 1 over 2. So that's another way you can do slope. I usually just look at the rectangle and do the rise over the run of the rectangle. Okay, finally, the foci. So for the foci, we know the foci have to go in here somewhere. So it's going to affect the x's. So again, I'm going to that center. I'm going to go right left for the foci. And I'm going to add and subtract c. Well, this time it is a squared minus b squared. It's a squared minus b squared. So, I'm sorry, a squared plus b squared. Let me clarify that. If this is minus, this is plus. So for the hyperbola, it's plus. So I'm going to add 4 plus 1, which is square root of 5. This is square root of 5. So sorry about that. If the hyperbola is minus, then it's a squared plus b squared. With the ellipse, the original equation is plus, and it's a squared minus b squared. Okay, let's just do one more hyperbola just because it's right, left versus up, down. Actually, this one is up, down, and the hyperbola is maybe the toughest one. But okay, so one of the things you want to pay attention to is, again, the x's, where the x's are and where the y's are. For the center, opposite of the x's is -1. Opposite of the y's is 3. So don't write it as 3, -1. It is -1, 3. But this determines the vertices. This time it's the y's, and we're going to go up, down, square root of 16, which is 4. So my vertices come from going up 4, 1, 2, 3, 4, down 4, 1, 2, 3, 4. So that affected the y's. So I'm going to add and subtract the y's, square root of 16, which is 4. We went up 4, down 4. So again, you know, if I wanted to do a sketch, that's what it's going to look like, going up, down. Those are the only vertices, but we do go right, left also. We're going to go right, left, square root of 25. So from the center, from that blue center, I'm going to go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Maybe I'll even put X's because it's not really a point. It's just 1, 2, 3, 4, 5. Now it's, my point is a bit off here. 1, 2, 3, 4, or should I say my non-point? Okay, that's my rectangle. I'm going to, again, kind of get rid of these. This is just so I remembered. -1, 3. Now we're going to do asymptotes. So through the corners of the rectangle and through the center. And again, we're going to kind of use the asymptotes as a guide so we know kind of how fat or how skinny to make it. And then it's going to go through the vertices there. So those red ones on the right and left, those are not really points. It's the black graph that's the actual graph. The foci have to go in here. So that's going to affect the y's. And again, c squared, because the parabola is we're subtracting, I'm just going to add the denominators. So that is 41. All right, so that was the graphing the conics. The last video is going to be on the 3 problems where we're writing the equations.